because academic loves the PowerPoint slide, so this won't be any different. I'll just bring that on. So yes, tonight I'm going to just talk a little bit about understanding the function of brain and the regulation of overall health. Now I've only got 30 minutes or so to do this. This is going to be quite tricky for me as well because I'm very passionate about this subject, and I think it sits in really nicely with the talks that have already gone and the school itself and how we can look at our own mental health. So really, when I go through this lecture tonight, I want you to think about yourself first and foremost. You're the aspiring psychologist of tomorrow, and you're going to be looking at your own mental health as well as others as well. But just first, beautiful brain. My interest and passion has always been about brain health. It's always been about the functions of the brain, and I was really interested in eating disorders as a student as well. And after working in a psychiatric department for a period of time, I was very conflicted about the actual causes of eating disorders, and it led me back to the lab, and I did some psychopharmacology, and I looked at the biological basis of eating disorders. So I spent 4 years studying two areas of the brain. That's how complex it is. And looking at feeding regulation and emotional centers. So I'll bring up some of that later on tonight. So I'm really passionate about this area of regulating brain health. But currently, I'm actually involved in a Take 5 to Age Well project that we launched last September. And within this, I've been able to work then as the psychologist looking at behaviour change, looking at how to bring in brain health and emotional regulation into this current project, because there are 5 pillars for aging well underneath this, and some of these are fed in then to what my previous research was about, which was eating disorders. So you can see in nutrition there, and hydration, physical activity, cognitive and social. So within those pillars, I've been able to build in a little bit of what the brain's actually doing when we do things. And actually, Peter bringing in the whole January and dry January and New Year's resolutions. We're going to look at dopamine tonight as well, because it's the hormone responsible for all that. Yeah, let's go 1st of January, and depletes very quickly, probably by the 5th or 6th of January, even before that. So this leads me on then to a public talk I'm going to do, because I'm very interested, as I said, about the biological base feeding disorders, but has led me on to sort of intuitive eating. So in April, I'm going to give a talk about ways to look at intuitive eating and brain health as well. So again, I really always think that brain health comes under this big umbrella, and then from that you've got lots of different pillars then that can actually work, but at the core of it is this beautiful organ that's working really, really hard then for you as well. So let's just have a little bit of fun. You're not going to be tested on this, okay? So you can actually relax and let us do the work for a change, okay? So you can sit back and relax. I've actually just a short article there on Open Learn. You can see the link there, a hug for the brain. So I'm looking at ways of regulating and promoting brain health. So there's a link there for that. I'm not sure if you get the slides, but if you look at Open Learn, a hug for the brain, you'll find that article there. So just some facts. The brain weighs about 3 pounds. I don't know if you can see my brain behind me. I also have this brain here, a smaller stress relieving one. It's got 100 billion neurons. So let's just think about that. Just stop there. 100 billion neurons. Okay, so that's why it's really complicated and complex, and why I studied 2 areas of the brain for 4 years. So it's a very complex and beautiful organ, and there's lots of different parts to it. So we're going to get the overview of it tonight, the bigger ticket numbers, and there's lots of other details in, and I have lots of references at the end that you can read up on some of the other work that's been done. Okay, so the brain triples in size, but isn't formally formed until about the age of 25. I like this one. It's enough electricity going through your brain to, power a light bulb. And 60% of the brain is made up of fat. So anybody who's now in their whole health kick, which feeds in nicely to my intuitive eating thing, the brain loves fat, it needs fat, and it's a really good regulator. Okay, so it's essential for your brain to actually work efficiently. So it kind of conflicts and is very conflicting with the information out there about body shape and body size and all of that. The brain's actually one of the organs that does need the fat then to actually work efficiently as well. Okay, but let's go back a little bit, and this is why I'm fascinated by how much we've actually progressed with the brain, our technology, etc. Cognitive psychology, for example, is a relatively young discipline, and so is neuro, and so is biopsychology and psychopharmacology and all these different areas. But we have known a lot about the brain, and a lot of the times you'll find that psychiatrists have come in and actually looked at areas of this. So Brodmann was the first. Then he was a German psychiatrist, and he looked at anatomical brain mapping, which was really useful. So he came up with 52 areas of the brain. And the reason why I'm showing you this is that because even though it's been widely debated over, I suppose since then, um, it's still widely known now and actually used most frequently in the mapping of the cortex. Now we've got over 200 areas now, but again, a lot of those areas that he identified have been now split into different parts because we understand that they've different functions even within one area. Okay, so what do we know? Um, we as psychologists have already known this. That the interplay between the biological, the psychological, and the social is actually really, really important for us. Now, Engel actually wrote a paper. You'll come across it if you haven't already as psychology students. The biopsychosocial model, the bio being the biological, the psycho being the psychological, and the social then being that social part of it. Um, and it has widely cited, and the World Health Organization use it, and we know that we need to look at all the interplays between it, but in fact the impact of the biopsychosocial model hasn't made as much of an impact as you would have thought based on the citations. And the reason for that is because it's so complicated to be able to do all three. It's so complicated to be able to study all three. But as our techniques, I suppose, expand and increase, we are getting more knowledge and areas within each of those then to study. And that's why the 5 to Thrive pledge for aging is quite interesting for me from this side of it, because I'm able to look at the biological, the psychological, and social in terms of a behavioral change type of project too. And from that, then we'll dig a little bit deeper into the biological side of it as well. But for now, because this focus tonight is on the brain, we're going to focus on the brain from a mental health perspective, and look at it from biological as well. So we're going to look at it biologically and what happens when it comes to the mental health side of it. So I suppose we're looking at the impact on mental health. The brain can work against you. It does. It continuously does. It baffles us at times in terms of that, in terms of emotional regulation, but it also has the ability to recover and respond very positively. So we're looking at the gap between some of the literature and some of the current research that's known about this as well. So what happens biologically when we reduce our levels of stress and depression, improve our happiness? So a lot of the research that's been, especially when Engel came out with the biopsychosocial, was like, let's look at all the psychological ways of all the problems with the biology. Well, in fact, neuroscience is slightly leaning more, and I suppose probably in about the last 10, 15 years, COVID has definitely increased that. It's looking about ways of increasing happiness within the brain. And you've got the positive psychologists to thank for that as well, looking at increasing those happiness instead of trying to work out why there's depression levels, etc., and anxiety. Let's look at trying to instill this sort of happiness idea into the brain. Now, it's a lot more complicated than that, but this allows us then to study it in certain ways and in certain areas as well. Okay, so what is cortical organization, brain anatomy, all of these wonderful things? Brian, as he's known, behind me here, what's all these different parts of the brain do? But first, and it's a very simple model of the brain, and I know we're all on computers and we can look up brain images. When I first started neuropsychology many years ago, I made a paper mache brain, which then went off after a while. After a while, I had to make a new one. Now we have lots of technology, but in fact, it can be quite simple. So I want you to look at what's on the screen, which is the hand model of the brain. Again, Daniel Siegel, he's actually a psychiatrist, and he's looking at child development a lot. So he would actually be explaining the brain in terms of children, and explaining it to parents and looking after brain health as well. He does a lot of work on ADHD. But if we look at it simply, and I'm going to do it, and you can do it with me if you want, but we're going to look at this because it's the perfect sort of, it looks like a brain when you turn it sideways. So if I look here, and this part of the brain is the older part of the brain. It's the mammalian brain. It's the oldest part of our brain, but it's really responsible for automatic processing. If I take my thumb and I put my thumb here, this is where around this is the limbic region. So you've got your amygdala, which we're going to talk about in a few minutes, and you've got your hippocampus. And you may have heard of these brain regions if you're in D120 module, but the hippocampus is memory, the amygdala is emotions, and you've got all of these around this. Okay, so this is the oldest part. Now, the newest part of the brain is the fingers. Okay, so this is the prefrontal cortex, and this is the cortex, sorry, this is the prefrontal cortex here where my fingernails are. And the reason why it's so good is because it shows the sort of shape of the brain. This is the brain stem here. And right behind here at the back of the head is what's called the pituitary gland. And it's the most important gland in the whole body, because it regulates a lot of the hormones. Well, sorry, it's the one of the most important. So the idea, if we have here, we have all these systems underneath here, but in fact, the common layperson's phrase of flipping your lid is very, very, very relevant and actually very applicable, because when you flip your lid, your oldest part of your brain, which is sometimes called the monkey part of the brain, is actually then the one that is in mode and actually working at that point. So when you flip your lid, your prefrontal cortex, which all your reasoning and your thinking and logic, flips out of the way, and this older part of the brain's actually working. And I've said this before in other talks I've given. I liken the limbic brain kind of to one of my sisters. I have four. Who gives really, really bad advice. Really important member of the family, really bad advice all the time. So this limbic system, again, it doesn't think, it doesn't logically think. However, if I'm in a situation where I need to get out of that, I'm in immediate danger. I don't want my prefrontal cortex doing all the thinking. I kind of want the limbic system reacting to get me out of there too. So really, if you're looking at emotional regulation, you're really trying to focus on, if this is coming up and these fingers are coming out of the way and it's going to flip the lid and you're going to flip the lid, then you need to start regulating it. Not when it's here, because it's too difficult to actually start regulating it there. Okay, so you need to bring it down. So if you're ever trying to visual what's actually the brain itself, it's the best one. If you don't have a model like I have, this is the best one then to think about overall brain health and thinking about these areas underneath here and all of these important, and this wrapping around of that prefrontal cortex as well. Okay, so what is it? There's three parts of the brain. We can't get into detail tonight, but the hindbrain, the midbrain, and the forebrain. So the hindbrain's responsible for movement, automatic processing. The midbrain mediates and blocks the sort of sensory. It's kind of the gatekeeper, if you like. And then the forebrain, which is the one that we're going to look at, it contains the cerebral cortex and the subcortical limbic system that we've just talked about there. So these are the parts of the brain that psychologists and neuropsychologists tend to look at more, because they're looking at it a link to mental health too. So that's the important distinction. Okay, so there's what it looks like in a hierarchy. So if you think again, this brain, this wrapping. So that's the part then that we did with the hand demonstration then as well. And we're going to look at the lobes now. So whilst we focus on this forebrain, sorry, I should have put my arrow on the right screen. So we're going to look at this forebrain, and not so much the midbrain and the hindbrain, but the forebrain then is where the center is, where we look at the actual different sections, and these are called lobes then within that. So the forebrain's organized into these different sections called lobes. Very simplified, but each lobe has a different function. So the frontal lobe, executive functioning and attention. The parietal lobe is motor sensory. The temporal lobe is hearing, and the occipital lobe is visual processing. So what does that actually look like in terms of the model of the brain then? You'll see that this is color coded as well. And if you look here to the front, this is where my fingernails would be, which is right here. And this is the problem solving, emotional traits, and all of that, the reasoning, the logic, the newest part of our brain. And to the back is the parietal lobe, which is knowing right from left, sensation, reading, body orientation. The occipital lobe is right at the back. So that's why sometimes if you get a knock to the head, it'll affect your vision because the occipital lobe then is damaged. And you've got the cerebellum and the brainstem as well, which are important in terms of overall balance and coordination for the cerebellum. And then the brainstem actually takes in the breathing and the body temperature as well. And then the temporal lobe here. And this is where the hippocampus then is within actual, when you talk about lobes themselves as well, this distinguishing the parts of the brain and where the lobes are can be quite useful for you to understand the different functions. However, I would say this is it's very complicated when it comes to it. We can try to separate them out based on where we see the most activation. But again, certain areas of the brain can be activated from, say, for example, you're looking in the occipital lobe and you're looking at vision, something could be affected back there, but it can actually have an impact then on the frontal lobe because of the problem solving or whatever you're saying. So the cognitive psychologist would be looking at all of these areas of the brain and how they interact. And that's what we want to understand a little bit more. What's the interaction of all these areas of the brain and how can we make sense of that in terms of a psychology community when it comes to overall mental health? All right, so this is quite complicated, but it's very similar to the slide before, slightly different colors, okay? But if you look at the frontal lobe, the parietal lobe, occipital lobe, and the temporal lobe, they're all there, okay? But acetylcholine, these are some of the chemicals that are associated with certain areas and are associated then with some mental disorders and actually associated with regulation and overall emotional regulation as well. So they do say acetylcholine, for example, and don't worry, you're not going to be tested in any of this. Acetylcholine, too much of that can lead to depression. Too little of it in the hippocampus. Now, remember, the hippocampus is responsible for memory. That can actually cause dementia or can be linked to dementia. Dopamine there, and dopamine is that driving hormone that we're going to look at in a few minutes. Too much of that, schizophrenia, too little depression. Serotonin, which we're going to look at as well, which is your mood stabilizer. It really gets in there and helps stabilize moods. So too little of that can cause depression and some anxiety. And then we've got GABA as well. And too little of that can actually cause anxiety. And some of the other ones there. So you've got norepinephrine, which is linked to increases in that are linked to schizophrenia, and decreases of it are linked to depression. However, kind of putting something like this in a chart or a graph like this here, it's showing the complexity of how these chemicals within the brain interact with each other. And that's the important part. So different chemicals have different interactions, but you can see here, depression's mentioned quite a few times and anxiety as well. So they're interacting and the interplay between them is actually quite important for it. So what's the brain always trying to do? The brain has actually two functions: survival, which is really good because it needs to aid your survival, and pleasure and reward. So whenever there's an imbalance, it's always trying to regulate itself. It's trying to bring you back to this sort of equal place where it can actually control it. Unlike the cat there that's not doing a really good job, your brain then when it sees in has increases and it's trying to regulate your mood, and that's why sometimes you may not feel good in certain ways. It can affect your stomach and things like that. It can affect your heart rate, all these things. And if I were to ask you now, if you were on mic and camera, what emotions do students experience? I'm sure the first one that you come up with would be pleasure, reward, your dopamine, because you know you're just loving life as a student and experiencing all these great modules. But the other one you might come up with at certain times is stress. So stress then is an it can be positive or negative, but stress is something that we talk about a lot. And the public groups that I've worked with too talk about stress, and it's very frequent mentioned in the literature. It's you know, we talk about it between ourselves and how we're feeling stressed. And some amounts of stress are quite good. But when it comes to higher levels of stress, it becomes distress, and that's when the body, and that's when the cat, if you think about that image, is trying, your brain is trying to equalize or bring it back to some sort of equilibrium, and that can be quite difficult as well. So the stress response increases, but it's not only just when you're feeling stressed or something's happening. It can actually be when the body's trying to fight an infection, and it can also be when it's enjoyable. You can find a little bit of stress in the body too. Emotions, you know, such as joy, anger, fear, are potent stressors as well. And expectations can also trigger this stress response. So you don't even have to experience anything stressful. It's the anticipation and the expectation. The brain doesn't know whether it's and you're expecting it or it's actually really happening. If you're thinking about it and feeling it, then it's going to respond, because that's what it's there to do, is to aid your survival too. And that's not just me saying this, we know this. We know this through the biological response in the body too. So we've got this hypothalamic pituitary adrenal axis, the HPA axis. And remember I said to you about the pituitary gland, which is at the back of the head, which is one of the most important glands then responsible for that. And it actually releases this corticotrophin releasing factor or hormone. And it's widely believed that it will mediate the stress-induced behaviors. So it's actually implying this sort of broader integrative role for the hormone in psychological stress response. So your body and brain are very intuitive and very clever, and they're responding and reacting a lot to different I suppose different situations in the environment, different thoughts that you're having, any physical stresses. So there's a lot of things happening, a lot of things happening continuously within your body. And this is why when you say you're feeling stressed, I'm going to show you now, it involves so many areas of the brain. Stress doesn't just be a feeling of a feeling, oh, I'm feeling a little bit stressed. It actually involves the amygdala, which is responsible for emotions. It involves the hypothalamus, which is emotions and feeling behavior. Now, the hypothalamus was the area of the brain I studied for a few years, because it's got part of that area is called the paraventricular nucleus, and it's associated with feeding regulation. And of course, then when you're looking at eating disorders, that would be an area you're looking at. It's got the pituitary gland, then secretes this hormone. Okay, so it's the main one that you need to be looking at in terms of regulation as well. And then you've got the prefrontal cortex and the hippocampus. What's left? So stress doesn't just have this emotional response in your body where you're feeling a little bit uneasy. You've got all these different areas within the brain that are affected by that. You've got the amygdala, which is your fear. I'm just looking at time now, so I'm going to go through these quite quickly. So you've got the amygdala, the almond shaped, the two sides of the brain. There are two amygdala, one on each side of the brain. So it's your fight, your flight. Remember this limbic system, your amygdala is there. You want the amygdala working sometimes if you're in a situation where you need to leave it quickly. The problem is our thoughts can cause a reaction in the amygdala as well. Remember I talked about the hypothalamus. So if you're stressed, what happens to your gut? You start to feel it in your gut, okay? And the serotonin, which is a mood stabilizer, 90% of that's made in your gut. And there's a reason for that, because it's trying to stabilize things. So if you're feeling a little bit stressed, you're going to feel it there. And again, this comes through from the pituitary gland as well. It's the one saying, okay, there's might be a threat here we need to activate. And then in comes the hippocampus. It's going, I'm going to remember that the next time, because I know that was a stressful situation or stressful thought. So every time then it's stored and the hippocampus then is affected. And then a key in the prefrontal cortex, and this is where it's working and organizing behavior. And this is where the frontmost region of the frontal cortex. So it's planning and organizing behavior as well. So stress biology, I'm going to get to the good part now in a few minutes about what you can actually do with this, all of this information about your lovely brain. And what can you do then to increase that? So there's this constant barrage of glucocorticoids during chronic stress. We're not built for chronic stress. Chronic stress is long-term stress. We're built for acute. Okay, so we're built then if we see something very stressful in the environment, we're actually built to I suppose the amygdala and the limbic system coming in and getting us out of that situation. We're not built for chronic stress over long periods of time. So it can actually affect our memories, it can affect our judgments, our decisions, so again, it's overarching across that. And then we look at some of the brain imaging data, and the volume of the hippocampus and the areas of the prefrontal cortex is lower in people with depression, and activity in the prefrontal cortex is reduced as well. Okay, so neurons. So again, I've talked about all these brain areas, I've talked about these lobes, I've talked about these function, but what is actually happening within these areas of the brain? 100 billion neurons, and they send messages to each other. And some of these neurotransmitters, and we're going to look at some of these, are glutamate, GABA, adrenaline, serotonin, dopamine, oxytocin, endorphin, and acetylcholine. They're all really good and useful hormones and neurotransmitters, sorry, only if they're in and the correct amounts, and you're regulating them correctly too, because we saw with that other brain image slide that increases and decreases can actually have an impact then as well. So the neuron sends messages. It's like a little courier that goes along, and their synapses and the neurotransmitters then are transmitted from axons to dendrites. And then if you look here, the synapse is actually what locks in and sends these as well. And the action potentials then are these, I suppose, electric energy then, and they can reach a speed of 150 meters per second. So it's all happening so fast. So how do you regulate that as well? And then anything is carried by action potential. Taste of music, or taste of chocolate, sorry, sound of music, smoothness of a pebble, all of these lovely things that come in and increase that brain activity is really, really good. Okay. So, happy hormones. Let's get to how we can regulate some of these things. So, what I said to you before was this increase in happiness in the brain can actually help that. So, if we look at a neurotransmitter, it's not usually it's the chemical that will want to make you feel better. Okay, your body can't function without these. And remember, if we look at those acts and potentials across, it's trying to carry chemical signals from one neuron to the other. And I have four here: dopamine, which is your drive hormone; oxytocin, which is your closeness and your oneness, probably depleted quite a lot during COVID because we couldn't have those connections that we need. You've got serotonin, which is your mood stabilizer, comes in and helps regulate that. And then endorphins, which is for ease, and that helps ease the body, and it's actually analgesic as well. So how do you get them? Um, this dopamine gives you motivation, oxytocin gives you the feelings of trust. It's also called the love or cuddle hormone, which I quite like. It plays a role in bonding as well. And then you've got serotonin, which is what you would look at if you're looking at stabilizing those moods and accepting yourself and others as well. So it's a very mood stabilizer if you're in different situations as well. And then you've got endorphins, which release these, and euphoria to I suppose, mask the physical pain as well. And this response to pain and stress alleviates that anxiety and depression. So whilst we're looking at all these different areas of the brain and the chemicals and how they build and all of this here, we can also look at then ways of increasing this happiness. So let's just look very quickly at deficiency. So they're what you would be feeling then if you were deficient in dopamine, procrastination, because remember it's the drive hormone. And then you look at oxytocin. If you're feeling lonely or disconnected, it can actually affect your sleep as well. Serotonin, low self-esteem as well, mood swings and all of that can actually have an impact. And then you've got endorphins, which is your anxiety and your depression and mood swings as well, and aches and pains. So the four of them have a connection between each other because they can be linked in certain ways as well. But if you're looking to know which one that you could actually increase and improve, And alongside of that, looking at some of these could actually reduce the stress levels as well, because you're looking at overall brain regulation in terms of that. Okay, so how to increase them? Meditation, doing daily, I suppose, to-do lists, etc., exercising regular for dopamine, physical touch, massage, acupuncture, listening to music for that one, serotonin, which would be exercise as well, and sunlight, massage, and then you've got endorphins. There's different strategies for it. Um, Laughter and crying for the endorphins is great too. So what you're trying to do is, I suppose, in terms of knowledge of the brain, is trying to work out where it is that I feel I have a deficiency and trying to increase that. Now, if you look at that chart there, there's one that falls into each of them. And it's one that people will probably be engaging right now because of the time of year that we're in, and that is exercise, because everybody loves to exercise, okay? And most people will say no to that. There are a group of people that will say yes. But what I think as well, and I'm going to show you this next slide, is movement is very powerful for the body, and the movement part of the body. So I'm suggesting that if you can't do all of these things, or you're not sure what hormone you need to increase, start moving your body, because movement will allow you to tap into your body, tap into that wisdom too. If you're not moving your body, you're not connecting with it, and that can be actually a difficulty then in knowing what you need to regulate too. Now, I have exercise stroked out, because I've asked this before to people, how many people in the room do triathlons or do yoga or do this, and then you can see the hands raised up. And there is a stigma associated with all of these. And what I would say to you as well is, movement and exercise don't need to be the same thing for you. Movement can be just a meditation as well. Movement can be you meditating and figuring out what your body actually needs at that. One of the best ways I do it, sometimes sitting at my desk, is working out where the tongue is on in my mouth. If it's up to the top of my mouth, then I know I'm feeling a bit stressed. But I only know that because I'm feeling the rest of my body too, and my shoulders as well. So those little charts will say to you, and a common one across them is about exercise. But I would look at it in terms of movement and seeing what you could do then to improve that overall regulation as well, and looking at ways to tapping into your own innate body wisdom, because you have it, because your brain is very clever and it's trying to work for you as well. Um, so just to finish off then, I just want to show you a few of these brain scans, because again, if you were, this is where regulation of brain health is quite important, and I've got extra reading for you there. In that area, is that you have to look at your own brain and its own health then to understand what way you could increase it or improve it. So if you look there, yoga boosts brain function, okay, which is great. But also if you look at this brain after sitting quietly, and then the brain after 20-minute walk, I would say if this brain, I'm looking at it, is lacking in dopamine and drive and motivation, and actually the walk has helped this. But I would say this brain here is actually overstimulated. It might be a little bit anxious. So in fact, a meditation would be really good for this person and this brain here to actually go and do an exercise or a HIIT class might not be the best thing for them. So it's tapping in to what your brain's actually telling you. And the only way to do that is through short meditation, sitting quietly, or doing some movement as well. It doesn't have to be very, very long. Like there's this idea about meditating that you must do an hour, you must empty everything from your mind. If you're not meditating at all, a couple of minutes meditation could actually really improve your overall mental health too. Okay, so I just want to, this is a lovely article because it looks at these discrete positive emotions that I'm talking about, because it's going to increase all of these as well. So you look at the dopaminergic system, which we looked at, dopamine, okay, and this then comes out to all these positive traits. And actually you can see some of the hormones and neurotransmitters that we looked at tonight. Oxytocin's there. Oh, opioids is there, an endogenous one, serotonin as well, and actually can cause some of these and result in some of these lovely nurturing, positive, discrete sort of attitudes. And promotion of brain health then comes into play really, really nicely when it comes to all of that. Okay, so I've tried to summarize that really quickly. Again, what I'd like to say to you now is that you've got this really powerful, wonderful brain working for you, okay? And it is so important in the regulation of your own health. but it's very individual. And back to that biopsychosocial model of health, that's maybe where the complexity comes in and why we can't look at it overall. In fact, it's so complex because it's based on an individual person, and we're not maybe getting into the individual core of it. So the brain is a powerful organ, but it can also be the cause of distress and low mood. Um, if you know from the charts, some of the hormones can help you increase your feelings of happiness. You just need to decide on what hormone you're lacking and how you can actually increase it. Be careful with dopamine. Really powerful hormone, but it's also responsible for addiction. It's very eager. It's the one on the 1st of January going, yay, let's go, let's go. And then by the 6th of January, it's depleted very, very quickly. So you're going to take it slow and connect with your own body and think about how you feel and start with small steps. And this is why I'm so interested in this side of research now that I'm doing, especially with the current project we're working on, because it's tapping into that sort of innate body wisdom that you have and then looking individually at it as well. So preventative measures are key and increasing happiness. And there's this idea that the brain doesn't know how to multitask. It shifts really, really quickly. So if it's you're working on happiness, then it could actually then decrease then the others because of this focus as well on it. So some the references there, looking at hippocampal and suffering from depression, mood disorders. There's lots of good research in terms of looking at the applying of the learnings from neuroscience to stay in workplace happiness as well. And there's lots of different ways of looking at how we look at the brain mapping as well and how we understand this, the regulation of the hormones within the overall brain and the overarching brain as well. So just to finish on this, what's new in neuroscience? Gut. So remember I said to you about serotonin, 90% of it is made in the gut. So I'm looking, especially my intuitive eating part, I'm looking more at gut feelings and how these are linked to emotions and emotion regulation too. And this one here, love builds brains, and looking at attachment and child brain development. And then resilience training as well. Like this, counselors would talk a lot about resilience in clinical practice, but what does that mean in terms of changing the brain? What does actually resilience do? And that's a really good article showing you actually what it's doing to the brain as well. And this doesn't mean anything. It's not relevant to this, but it just makes me happy because it's all my favorite things, but your dogs as well. It's usually cats or dogs with the shows. So thank you so much. And sorry, Peter, I've probably gone over a little bit of time there as well.
That's okay, Sinead. I was gripped, I have to say, and not just when the dogs came up. I'm glad the dogs came up, um, because I'm gonna overshare now. But I'm one of the 8,527,000,000 people who got a dog in COVID.
Oh yeah.
And I do think my dog was a very, very major oxytocin releaser for me. And I think that's, and when you said, we probably needed that in COVID, I thought, oh, I bet that's why we all got dogs, far from anything else.
And
Put a little on.
there's no better way to actually alleviate those is get a dog. That's in terms of that closeness and connection. That's why
Absolutely,
pets
yeah.
work really, really well for overall mental health as well.
Yeah, and I was reading that you do when you bond with your dog and you do the eye contact and everything, it is, it's like a baby, and you spike each other's oxytocin like crazy. Um, that's great. There is a range of really interesting questions in the chat. And yeah, we don't have a huge amount of time for questions, but I think everybody was gripped and very active throughout that. Um, I think one question that I think is not surprising is there's sort of a few questions about the extent to which different forms of psychological stress, you think schizophrenia, anxiety, depression, were all, to what extent can those be addressed by drugs, and to what extent are they something else? And I think a view expressed in the chat is that sort of, I think, maybe counters that, is that are some of those kinds of things normal reaction to very, very adverse, unusual kinds of circumstances? Are they
Hmm.
are, are they are they an effect of that? So I just wonder if you want to riff on that general theme for a little bit.
Okay, so I suppose when you're looking at we look at sort of psychopharmacology and that side of it in terms to and this is the thing when I talk about equilibrium of the brain. So if something's happening organically, like biologically in the brain, it's trying to shift that, or something's happening environmentally. And that's why the biopsychosocial model is so complex, because we don't have a handle on all of them that well. And that's why you see psychiatrists will go in more into the neuroscience of it, and you have psychologists then in the other
Mm,
side of it.
mm, mm.
So it's like bridging these two together.
Yeah,
It's really complicated, because it's kind of like, if you look at nature nurture and that big debate that's going on,
yeah,
and the
yeah.
whole idea which one comes first. What the way I would look at it always was, and even as a young student in this area and listening to lots of talks, and it was just like about promotion of your own brain health and preventative. And that's why the resilience part's actually quite interesting, and because
Mm,
it's looking
mm.
at what way does the neuroplasticity of the brain actually work in prevention of some of these too. So it's like the old thing of needing a psychologist. Well, a lot of people will turn to a psychologist or counselor once they're in a traumatic state or something has happened to them, whereas in fact then it's way before that in terms of education and psychoeducation, in terms of
Yeah.
overall. So yeah, I think it's getting in at a younger age. That's why a lot of the sort of developmental psychologists are looking at risk behaviors in terms of mental health too. I don't know if I've really answered your question there,
You have,
fully.
and I think, it kind of touches on, I think, something else. I think was we definitely mentioned in the chat, maybe not the top theme, but there was a few people, I think, kind of like thinking about this question around brain flexibility, neuroflexibility. It's very interesting, isn't it? Because I think, when neuroscience really started to make a big dent in psychology around 30 years ago, when I was but a lad, the narratives were very much around fixity. Do you know what I mean? This is the brain part that does this. This is the brain part that does, this is the brain part that makes you this way. This is the brain part that makes you that way.
Hmm.
And I think over time, neuroscience has come to talk much, much more about the flexibility of the brain,
Yeah,
and much less about the brain as something that kind of leads to a set of fixed determinants and behavior. So it was
yeah,
interesting to hear you talk about that. I really heard that when you said, your brain is not fully developed till you're 25. I mean, that's quite an age, really, for a
yeah,
human,
yeah, yeah.
That's a good proportional lifespan right there.
But the good
So
news
yeah,
is, the good news about the 25 is that it develops by 25, but the plasticity of the brain is always changing, always changing.
yeah, yeah,
So,
yeah,
and again, if you look at just those are four simple basic hormones that you would look at in terms of it, like dose, and it's a good acronym to remember. But again, what the underlying factor is about getting in and actually increasing them and getting this in your tool belt to begin with, and looking at overall ways of increasing it rather than coming to a point where you need to go, okay, it's like meditation. Nobody is going to meditate
hmm
effectively when they're in a crisis point, because they're already in that crisis point. It's like somebody sends you calm down. Has anybody ever calmed down by being told to calm down? It's the brain is constantly grappling with this here,
yeah,
and again, it's trying to equalize it and provide this sort of balance for you as well. Yeah.
yeah. One of the questions on the chat early on was questioning the link between serotonin and depression. Are there two sides to that argument about
Sorry, what was
serotonin
that
and
first
depression?
part? I was just looking at the chat.
Questioning that, yeah, yeah, early on the link between serotonin and depression.
Oh yeah, yeah. So serotonin, if you like, if you look at SSRIs, right, that's an
Hmm.
antidepressant. So what they've done
Yeah,
is serotonin, and this is actually a really good. And I was thinking about more time, I could have went into that and into this. So
yeah, yeah, yeah,
your brain actually makes serotonin. The drug doesn't make the serotonin. What the SSRIs, which is also known as antidepressants, do, it gets into it. It's called a selective serotonin reuptake inhibitors. So it gets into your brain and actually takes the serotonin that's already made in your brain and reuptakes it and reuptakes it and reuptakes it. So you remember I showed you about the locking key of the synapse and the dendrites.
yeah.
It almost does that. So it's something that's already made. It's something that's made in your brain. It's just dormant for whatever reason, for your mood, etc. So it's getting in there and trying to increase in that too. I'm not saying that don't take antidepressants. That's not my position on any of that.
Mm,
I'm
yeah,
saying alongside of that, there's so many other things that you could be doing then to increase that overall as well.
yeah. Great. The questions are now coming in quite thick and fast towards the end here. There was one earlier. Somebody posted a question because sexual desire was one of the happy emotions that you had, and
Yeah.
somebody said, "What would you think about somebody who doesn't experience sexual desire?"
Yeah, you're talking about the libido and a lack of that. Again, some of the studies I've read is about looking at what you were before and the comparison to that. Okay, so sexual drive can be innate as well, and you can have a low libido for many different reasons. Okay, so it mightn't just be
Yeah,
necessary
yeah,
as a reaction to a mental health issue. It's about it's about not comparing to other people, but looking at overall what's your continuum of mental health too is. And the only reason why you look at sexual desire is that has that changed for you? Has that decreased as it would have been normally? And that's an indicator then that something else is going on then for you. And sometimes you need to actually plug yourself into those areas and see what you can then promote or regulate in terms of that. So again, it's not about, this is why group and looking at people as groups doesn't work so well with brain health because it's so complicated and it's all about
mm.
you and what you're feeling. But if you're not paying attention to it, like the way I said about the tongue up to the top of my roof of my mouth, that's my own personal indicator that I'm feeling stressed. Okay, my shoulders are
Yeah,
here. The only time a tongue needs to be up to the top of the roof of your mouth if you're weightlifting, right? I'm at my desk, I'm not weightlifting. Okay. So then I know, okay, I need to actually take a break. All right. And that's it.
yeah, yeah,
And
yeah,
there's the snobbery in everything in social media. And I love social media and I think it's great. But there's a snobbery about mindfulness and meditation and all of this. If you're not meditating for 5 hours, then what
yeah,
else are
yeah,
you doing? So it's like it's taking it small incremental steps and just in looking at your own health, what it was the day before, and tapping into that innate body wisdom because it's there. The brain is
yeah,
really help
yeah.
trying to do that. It's just we're not listening most of the time.
Yeah. Yeah, it's very interesting. It's very interesting. And then I think just recently a question has dropped into the chat as well. Is there I've seen a couple of studies about the prevalence of EDs, eating disorders, and ASD, with the data showing an increase among those diagnosed on the spectrum. Could that possibly be related to neuropsychology? Do you know
Yeah,
anything about that?
the eating disorders one, I could only talk to that one, but not the ASD. But yes, it's
Okay,
it's 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 really really complicated because the eating disorders research in terms of the biology of it, and again I said that I studied it for 4 years and it's so super complicated and what the outcomes are for it. We do know that um there are issues within the sort of hypothalamic pituitary and amygdala regions, the paraventricular nucleus as
okay,
well, that regulation isn't actually happening. And ASD has shown the same, that the underarching
okay.
regulation is disrupted by something. Again, this goes back to the biopsych. Where's the disruption coming from? Is it
Sure,
organically? Is
sure.
situational? Is it genetics? Is it what's actually happening to cause the disruption? So as you said, we're really good at studying the brain when things go wrong, but we're now trying to turn towards with positive psychology is looking at increasing the overall brain health in the hope that that'll help us understand the other areas. Now they have been doing that, but in terms of neuroscience and looking at the brain imaging is done more so when it's depression, anxiety and that and schizophrenia and that, but not the other side when it's actually trying to promote regulation of what you would call typically normal healthy brains and looking at increasing hormones overall in that one.
Great. And lastly, Sinead, there's a very practical question a few people have asked. Can we circulate your slides at the end of this
Yes,
talk?
yes, absolutely. And
Yes,
there's
great.
links and
Okay, brilliant.
research on that, and absolutely, I'm happy for any of that to be shared as well.
Okay, okay, fab. So if you can ping them over to me, I'll get them over to everybody who signed up for this talk, whether they're here or not.
No
So that's
problem.
great. Brilliant.
I-
Does anybody have a last question for Sinead before we thank her one last time?
I'm just looking at the chat now. And
Lots of thank you. That was really interesting. And you see, I told you folks, I told you you'd walk away feeling kind of like optimistic and upbeat after an hour of Sinead. It works every time.
but you see, I've built a career on talking for long periods of time, and that was a bit of a shorter one. So,
All
I've
right.
built that career about expanding on things, and I had to be sort of limited on some of the things. But yeah, there's some of those references will let you dig a little bit deeper into some of the areas that I was talking about as well. And happy to have this discussion as well. So it's a
Brilliant.
brilliant one to talk about too.
Brilliant, brilliant. I love it. I mean, I think it's so interesting. You think that when you get to the natural science end of things, you're gonna go away from the way that psychology is reflexive. But actually, you've given us like 10 new ways to be
Oh yeah.
reflective about our experiences tonight. So that's just fantastic. Sinead, thank you so much for
Thank
being our
you.
first speaker of 2024. Thank you everybody for showing up. Next month is Katrina Havard. I haven't put the link up for that yet on Sona, but we'll do that very shortly. Take care, everybody. Have a good night. See you
Thank
soon.
you. Thanks very
Bye.
much, guys. Thank you.
Bye.
Bye.